Hi, I'm Jason Andrist, and this is going to be the first episode of what I'm going to call JacFab'in Fridays, where I've moved my work schedule around to where I have more time to work on some of my projects one day a week. I'm going to record it for you guys. We'll stick it on YouTube. You guys can follow along as I make cool stuff. Anyway, today what we're going to do is I've got this slug of aluminum that's a circle, as you can see. It's all I've got, so what we're going to do is we're going to take this and we're going to turn it into a square first on the mill. This is a Haas VF2SS and it's pretty slick, but anyway, we're going to turn this into a square. From there we'll turn it into a test fixture, which then we will test. This is a prototype recirculation valve for LTG 2.0T. Commonly found in the Camaro and the ATS and stuff. This is your factory one that's obviously broken. But anyway, I've always theorized that this thing leaks. I've made a block off plate, I've logged, done some driving. I'm fairly certain that it leaks. So what I'm going to do, before I go any farther with making these, spending money and whatnot, we're going to test it. So we're going to take this, turn it into a test fixture. Not going to have time to obviously do the testing today, but anyway, we'll do all the hard stuff today, and then next week we'll take a not broken stock one and the new JacFab recirculation valve, and we'll throw them in a tank of water and pressurize them and actually see if this guy leaks and this guy doesn't leak. So basically we got to dump in some water, make sure it doesn't leak, make sure this one does leak, because I'm pretty sure it does. And then this one here, we can start moving into production. So anyway, stick around, turn this into a square, we'll go fire up the computer, we'll do a little bit of Fusion 360 so you guys see a little bit of that. I'll try not to drag it out too long. But anyway, let's get the mill warming up and then we'll go hop on the computer. Okay, let's go jump on the computer. Alright, so we're here in Fusion 360 and you can see some of the products that I've been playing with, projects actually. There's some blow-off valve adapters, recirculation valve adapters, some covers, a couple turbo adapters for the stock exhaust manifold. So anyway, I'm going to go ahead and start off by drawing a square 3 inches by 3 inches. Stop the sketch. We're going to push E for extrude, 3 inches, bam. So now we got a 3-inch solid body. So we're going to save that. That'll start the automatic saving in Fusion 360. And we're going to go ahead and jump into the cam side. Go ahead and make a new setup. And I apologize if some of this seems a little off. I had a computer crashed, had a new hard drive, so I'm just kind of doing a voiceover here based off of what I remember and what I'm kind of seeing, so bear with me. I'm not going to show you guys this whole thing, and I'll talk when it's important, but I'll just speed up most of the random stuff. So here what I'm doing is I'm fudging the stock for the square because for some reason doesn't seem to want to take a round stock and keep the orientation correct. So I was forced to basically tell Fusion 360 that the stock is a square with extra stock on the top side, and so basically that's gonna fake my way through it and let me turn that circle into a square on the mill. So I'll go ahead and speed some of this up here. I'll talk if I see something important. So here I'm opening up another part because for whatever reason every time Fusion updates for me it always loses my tool library. But you can always get those tools back by opening up another part that had previously used them, and then you can just steal them right out of there. So this will be our top
well, I can't say top, but sides, all four sides. And then right here I'm doing a second operation, which will just take a 32nd of an inch off the top and bottom that are already flat on the piece. And we'll post this and head back to the mill.
Alright, we're back here at the mill. I had some problems in Fusion. For whatever reason, it didn't want to take a round stock to cut a square piece, and it kept trying to move the stock orientation on me. So what I had to do was I fudged it, just said we're going to use a big square because all we're going to do is face it anyway. You know, we're going to face the top. Once I got that done, I can flip it over. We'll face the bottom. Once I got two flat sides, then I can grab it in the vise. We'll do the top and the bottom again. You saw I did a second tool path there. We're going to take a 32nd off each of the flat ends just to have a completely machined nice piece. Now what I didn't realize was these are a little smaller than I figured on, and so we're not going to have a real square. It's going to have rounded edges, but that's still going to work just fine for what we're doing as far as the test piece goes. So anyway, I apologize, I forgot my waterproof case for the GoPro, so we'll try and get some footage there and show you something. I'm sure that's what you're all here to see, but anyway, we'll turn this into a square and then we'll go from there. Okay, so here we go. Yeah, you can see something going on there, so that's all right for now. Unfortunately, part of the drawbacks to baking this and having Fusion tell me that it was a square instead of a circle is there's going to be a lot of air cutting.
Alright, so this is actually pretty boring, so I'm just going to go ahead and speed this up, blow past this, and then get into the Fusion again, and we'll actually design something useful. And then we'll stick the GoPro inside the mill. Maybe we'll get a little better action that's worth watching. So here's another view. This is actually the second side that we're going to do.
Okay, so now you can see that this is mostly square. It's got these rounded corners. The stock that I had wasn't quite big enough to get a full square out of, but that's alright. As long as we got these flat sides, it'll be easy to machine. So anyway, we'll go ahead and do a quick face pass on the top and the bottom on the flat sides, and then we'll jump back in Fusion and design the actual fixture. Come back out here, we'll mill it, and then that's probably where I'll leave you guys for this week. So anyway, stay tuned. Okay, so here we're probing the part. We're going to do our Z. Go to the side there, we'll do the X. And do the Y with the Renishaw probe. And give us our coordinates for the 0. So this is sped up again. And
unfortunately, this is probably the best footage that I have of the mill, seeing as how I left my waterproof GoPro case at home. So I apologize for that. I'll be a little more prepared next time. Face the other side. Gotta probe it again. And get rolling.
Okay, so we got our piece machined. It was a circle. Now you can see it's a square with round corners. Got a nice face on the top, nice face on the bottom. You got 4 flat sides to work with. So let's jump back on the computer. We'll model up the actual test fixture that's going to make this all work, and then we'll go from there.
Okay, I've got this sped up a little bit, so we're going to draw a circle on the center of this. That'll give me a nice center point. And I'm going to go into a part that I have made previously to copy all of the important stuff that I need. So we're going to copy this sketch, go back to the other drawing, paste the sketch, got to find the sketch. Okay, way over there. Now I will center the sketch on my circle for my center point, and then proceed to model off of that sketch. There's my mounting holes, and let's see here. I'm going to delete some of this useless stuff. There's my main bore, and that will go all the way through. Nice. I'm going to put a couple holes on the side. Hole on the bottom. It's going to be a boost tap for the JacFab unit. That hole there that I did into the chamber, that represents the recirculation area where it would normally blow off on your turbo and to be recirculated. So basically it's pretty simple design. There's not a lot going on there. So now I'm just camming everything. And I'm going to do all three, two or three, can't remember. Sorry. As I said, my hard drive crashed, so I'm redoing this stuff here. I think I'm doing 2 tool paths on this. One for the top, and one for the side holes. Okay, we're just about done here on the computer. Looks like I'm just finishing up. It's like a 2D contour. Chamfer. We'll set up our second operation for the side holes, and you can see here I duplicated the previous operation, deleted all the stuff I don't need, kept all the stuff I did, and just picked new geometries because I already needed to use those tools. So sometimes that can save you a bit of time in Fusion 360. Just duplicate, delete, change your geometry, bam. So we'll post these and get going.
Okay, we're back here at the mill. We got our tool paths. I went ahead and marked this. This is my top. X plus. This one side has a nice slit in it that didn't get faced all the way out, but it's not going to affect this. I got my bottom, this side where the holes are going to go, and basically I'll explain this after it's all machined and I can show you the finished part. So anyway, let's get back to milling. Okay, so we'll start here with the spot drill. Switching to a 199 drill bit for the mounting holes for the pieces. And you can see here I'm drilling with a full retract. And we're going to switch to a bigger drill bit. Drill all the way through our center. And I probably didn't need to do this full retract, but I don't know. I figured better safe than sorry. Here we're doing some rigid tapping. And this thing will put the tap in forward, reverse the tap and pull it out. Now, I find that this is handy because if you don't do this and you're not going through a through hole, the tap will plug with chips and break. So, food for thought. It looks like we were using a 1/2 inch end mill here and doing our big bore. And I've got this sped up again because it would take way too long and you guys don't want to watch the whole thing anyway. So here we're blowing her off. We're going to flip it on its side for the second operation. And of course we have to probe it again. There's our Z probe. Our X probe. And are we going to do a Y? We are going to do a Y. And we'll drill these 2 holes and we'll be done. Alright, we got our test fixture milled. As you can see, it used to be a circle. Now it's mostly square. It's got some pockets, got some holes, got another hole. Anyway, This section here represents your stock turbo. You can see there's a lip in here. Now, when you put your stock recirculation valve on, the stock recirculation valve piston is plastic. The plastic piston rests on this lip. There is no seal to speak of. Plastic on metal does not seal. It'll leak. So, what we're going to do next week here, this hole here in the bottom, I'm going to tap this for an air fitting. We'll hook this up to an air compressor with a pressure regulator. This will be our boost. So we put the stock recirculation on, open up the boost. This is your recirculation hole. Comes out into the chamber with the turbo. When you let off the gas in your car, piston comes up, your air recirculates out through this hole. Now what I'm betting is going to happen next week, we put the stock recirculation valve on, we put some boost to it, it's going to start leaking out this hole almost immediately. So, how do we solve that? The JacFab recirculation valve. It has a rubber seal. It will seal. I have made one before. It was electric. It sealed up to 60 psi. The problem with that one, it didn't open under pressure. So when you let off the gas, it would not open. That's not good. So anyway, went back to the drawing board, came up with this guy. It's got O-rings, it's got springs, it's got seals, yada yada yada. This works off boost reference. So we got another hole here that taps into our boost hole, separate from the recirculation hole. So anyway, we'll hook a boost line up to here. There is a spring in this, but it's not enough pressure to keep the piston closed under boost. So using your boost pressure plus the spring pressure, there will be more pressure on the piston than there will be on the boost side. That'll keep it closed. When you let off, there's going to be a magical solenoid that plugs into the stock harness for this guy. When you let off the fuel, the solenoid will switch this guy to vacuum. That will pull the piston up and allow the air to recirculate. You get back on the gas, solenoid shuts off, back to the boost. We're boosting, we're not leaking, we're making more power. So that's a good theory, but we're going to test it next week. So check out next week. We'll test these two back to back, see which one leaks, see which one doesn't leak, and if it looks good, we'll go into production with this guy. So anyway, thanks for watching. Sorry about the GoPro footage. I'm trying to get some better camera stuff in here in the future. But anyway, that's all the time I got for this week. So tune in next week, we'll do some testing, and then we'll find something else to work on.